Yeah, thank you so much. Good morning or good afternoon, everyone, depending on where you are. Our project title was Integrating Genetic, Agronomic, and Economic Approach to Improving Environmental Adaptability and End-Use Quality of Creeping Red Fescue. So to this project, a few of our colleagues contributed, and also to this presentation are Nobur Rahman, Calvin Yoder, and Talon Gauthier. So a little bit brief background to creeping red fescue, and it is a very popular turf grass in temperate and boreal region in the world. And Peace River region is the world leader in creeping red fescue seed production. In terms of crop area and production, the export value of this seed crop in 2019 and 20 was nearly 30 million. However, the seed productivity of this crop in Canada is lower than other competing countries. So the biology of this crop is that it is a perennial vernalization obligate crop. That means it needs extended period of exposure to cold, that is sub-zero temperature. That means it needs overwintering for seed production, for reproductive induction. That's why it takes about 3 years, actually 3 years for 2 crop years and 1 establishment year to complete the cycle of production. So I'd like to give brief simplified overview of what determines yields. And it is a genetics of the crops that is carried by cultivar and its seed that determines seed potential, but we cannot achieve the potential yield because environment presents constraints to realize that potential, and what is the interactive product of genetics and environment, we get actual yield. To expand that actual yield, and one approach is breeding, and that increases potential yield by expanding its genetic capability. Other approach is agronomy, lots of practices there, and that creates conducive, more favorable environment for crop and resulting in more favorable interaction that leads to overcome yield limiting and reducing factors, provide optimal growing conditions, and help realize the genetic potential. So that way we have a higher actual yield through breeding and agronomic approach. And for having genetic potential, what cultivar options do we have? And you can see in the list, this is the screenshot from a Canadian Food Inspection Agency, and we have only one crop cultivar, the creeping red fescue cultivar, that is named Boreal. That was registered in 1966. For last 56 years, this has been the dominant cultivar, although there were lots of proprietary cultivars introduced in the market. And we tested several proprietary cultivars compared to Boreal cultivar registered 56 years ago. You can see the first year real yield of Boreal here, and the experimental mean of several cultivars in the first year, and same thing in the second year of seed production. Boreal is always out yielder, and there were rarely any proprietary cultivar that are competitive enough to Boreal. So given that situation, we conceptualized the project that involved breeding component for better disease resistance and environmental adaptability, and agronomic component that involved plant growth regulation, plant nutrition, and stand health management. And we did some economics in terms of gross margin to determine the profitability of creeping rate fescue crop management factors included in this study. So yeah, coming to the population improvement, that is breeding, we started in 2018 with 4 populations that were available that created a base population nursery. And in 2019, we did preliminary selections of the plants which are more promising for desirable traits. And in 2020, we further validated those selections and selected 46 plants that had more desirable characteristics and created a polycross nursery by transplanting their clones. And those in 2021, we established polytunnels in the field for isolated polycross nursery over those transplanted clones. And in 2022, we produced those seeds in 2021 and created new synthetic nursery that we established for the seed increase and new cycle of selection that we are hoping for continuing beyond 2023. So to support our breeding effort, and we did some vernalization experiments, and that is a plant shuttle between unheated and heated greenhouse with application of plant growth regulators to induce reproductive transition in the control environment condition. So for that shuttle, we created a greenhouse, external unheated greenhouse, where we transfer plants from the heated greenhouse for acclimation and then vernalization, that is treatment for extended period of up to 4 months there to be able to have reproductive induction, then transfer those plants to greenhouse to produce seeds out of that. And so if these experimentation were successful, then we would have a more efficient, time efficiency in producing seeds, polycross seeds that would enhance the breeding cycle. However, unfortunately, in 2020, and because of COVID, we had to terminate that trial. And it's in 2021 and 22, we had a plant death during the acclimation process, and we are not able to have results of this. But this experiment is very important and crucial for greenhouse seed production, and we need to optimize this process and in the future through experimentation. So in the agronomy side, we had integrated crop management trials. We conducted 2 different sets of experiment. In experiment set 1, there were 9 treatments of various agronomic factors, including plant growth regulators and fungicide application and plant nutrient application. And those trials we established in 2018 and harvested for 4 successive years, and those established in 2019 were harvested into 3 successive years till 2022. So experimental set 2 involved 6 treatments, and those were established in 2019 with harvest year in 2020 and 21. And same experimental template we had, but we split those each treatments into 3 levels of residue management in 2022. So the results of 2018 establishment, 4-year results with different nutrient applications, stacking those factors, nutrients and other factors from nitrogen, phosphorus, potassium, sulfur, and foliar application of boron and fungicide Nexicor, application, and then plant growth regulator application, trinexapac ethyl plus chlorine chloride combination. So yeah, you see there was no response to treatments we applied in this trial. All those like 4 years in any of the treatments, that means the control was as productive as other treatment factors we applied. So same thing in 2020 established trial, but we can see little bit response to different treatments. Still statistically, the yield differences were non-significant in this. These are the results of first set of experiment. In the second set of experiment, that included 2 fertilizer application methods, broadcast and banding, and subplot. Those are main plot factors and subplot factors, boron application and plant growth regulator application. And still we don't see treatment response at main plot and subplot level here. So the possible reason for poor response, and one of the major factors is erratic weather that masked the treatment effect. And these are some of the weather highlights we had during our experimentation. And so year 2018, and that was conducive for lodging and harvest issues. And 2019 early season was very much favorable for heaving, and a lot of crops suffered from that. And 2020, and it was a relatively wet season, and it was the very disease season. We saw disease incidents that we had never seen before. And 2021, it was a heat wave of 42 degree, sorry, 42 degrees Celsius temperature, and for over a week. And so coincidentally, it is the same week that we had that 42 degrees Celsius in 2021 and around 0 degrees Celsius in 2019. So you can see the weather anomaly. So yeah, we try to analyze the relationship between the weather condition, temperature and rainfall pattern, and the crop yield. And in the preceding season, like the weather in the preceding season has an effect on following spring crop. And September weather condition, especially high temperature and high rainfall in September, that promotes a lot of regrowth, is counterproductive. That is, those factors are negatively correlated with the yield in the following season, while those temperatures and rainfalls in the beginning of the season, high temperature, and in the late season reproductive stage of the crop, high temperature were not favorable. Otherwise, for rest of the season, high temperatures and high rainfall had a positive correlation with yield. And I described the episode of the weather that had an effect on crop already. So other possible reason is baseline soil nutrient status, and the nutrient profile seems quite satisfactory. So this is a crop that doesn't need that much high nutrition and intensive management for seed production, looks like. And that's why these may be the satisfying condition for that. That's why we did not see effect. And another thing is its biological properties, rhizomatous growth, and if there is some management factor that enhance vegetative tillers, that is counterproductive for seed production, because vegetative tillers that are produced in the same spring, those are not vernalized, they do not produce seeds. And another thing is root banding that occurs very quickly in these crops that limits nutrient access to reproductive tillers. And plant growth regulator application that is widely used in seed production environments in the world, but that is beneficial only for lodging prone environment, luxurious growth environment. That was not the case in our situation. So that's why we need to revisit nutrient management regime in the future study for having better agronomic efficiency. So resultantly, this is economics, and you saw no beneficial effect of treatment added, and so added treatment had added cost, but the gross margin, those are lower than the control in most of the situation. So yeah, and obviously that is a 2019 result here, and a very similar situation, and these integrated crop management treatments did not have significant effect in gross revenue. That's why it doesn't seem to be profitable based on our results. And because annual input and application costs for treatment range from $182 to $520, and to offset those added costs, and we need to have 10 to 20% additional yield from different treatments. So we did not have that much yield increase because of that. So economically did not seem to be profitable. So from this project and other associated number of projects, and we had a number of publications, presentations in recent years, and also some technology transfer publications we had from that. With that, I'd like to conclude, and lack of locally adapted cultivar is a major constraint to creeping rate fescue seed production. We initiated breeding in 2018 and expected to continue it in the future. And there is ample scope of breeding and agronomic improvement in this crop. There are not much work previously done. So in the breeding, there is a need of identifying genomic markers for disease tolerance, dark green coloration, fine leaves, and seed yield for population improvement efficiency. Similarly, in agronomy, need to determine crop nutrient uptake losses and crop nutrient budget. As we saw in the first presentation, there needs lots of fine tuning, and need to revisit nutrient management regimes, and also need to do a study to track the changes in soil health and gaseous emissions under various nutrient management regimes, and identify effective management of post-harvest aftermath and stubbles, and for circular economy, how best we can utilize those post-harvest aftermath, and how we manage the stubble so that we have good response to following season crop. So similarly, there is a need of assessing the effect of deep vertical tillage for aerating rhizosphere environment, because this crop gets root bound very soon, for new roots development and nutrient access, and develop effective termination and cover crop options for rotational transitions. With that, I'd like to acknowledge funding and administration from Agriculture and Agri-Food Canada, Peace Region Forest Seed Associations, and Canadian Ornamental Horticulture Alliance. And similarly, collaboration from Calvin Yoder, who was formerly a seed specialist of Alberta Agriculture and Forestry, and now associated with Peace Region Forest Seed Association. Taylor Gauthier, who is a general manager of Peace Region Forest Seed Association. Similarly, our colleagues at Beaverlodge Research Farm for their expertise and technical support, Jennifer Otani, Henry Klein, Gibank, Nobu Roman, and Pat Gansel. And thank you so much for your attention. I'm sure you're waiting for the lunch, and we are behind the schedule, and I'll be pleased to answer if any questions you may have. Thank you.
Thank you, Nitya. We're only 2 minutes behind schedule, so not an issue. Does anyone have any questions for Nitya before we move on to the next presentation?
I've got one, Jamie. It's Al Sullivan. Thank you for your presentation. I was a little bit surprised that the red fescue did not respond to nitrogen. You would think with a grass forage crop like this, that would be typical. And so either it's a very efficient user of nitrogen or it just requires low nitrogen. I'm not sure which. And is it valuable to do more trials on nutrition? That's one question. And the other one is, if these are seed fields, have you thought of maybe managing the seed fields in a different way? It sounds like there's a problem with competition. Is there any way that you can manage them to reduce the competition between vegetative and reproductive tillers?
Yeah, thank you so much. And those are great questions. And actually, for nutrient applications, there were some studies done in the past, and some of the studies show that this crop responds to up to 60 kg nitrogen supplementation. Based on previous studies, and so the application timing is determined for the fall application, especially in the late September to October application. So we need to validate if it is still that is the relevant time and a good time for application, given that nitrogen has lots of fats and very sensitive to different form of losses. So yeah, that's why we are thinking of doing a nitrogen cycle study and what losses occur and what timing of application in the future. So for seed crop management for reducing competition, so in the past in Peace region itself, like there were some treatments applied, different burning practices, and some herbicide applications, and actually that had either no effect or sometimes negative effect because of a short recovery time for this crop. And for other parts of the world, let's say for in New Zealand, what they do is they graze sheep or cattle on the crop, so that way it reduces competition. And they browse those new emerging tillers, and other tillers like quickly compensate that with their growth. And so that is based on the study done in the past. That is not an option, again, because of very short recovery time, short growing season in our region. So actually, considering the significance of the crop, and the studies done are very limited, very few. So we need to explore a lot on this. And the thing is that we cannot, extrapolate the studies and finding from elsewhere, from, for example, Oregon, which is one seed production region, and their environmental condition is very different from ours. And so we try to have extrapolation of those results, and we tested those factors here also, but we find very different results, including the plant growth regulator application. So
yeah, you were working under some very, very difficult environmental conditions. I mean, 42 degrees centigrade. I mean, most places in Canada don't reach that temperature, let alone Beaver Lodge. So
that is exceptional.
Yeah, congratulations.
Yeah, 0 degrees to 42 degrees in the same week. Like in 2019, we had a problem, and so the heads of those reproductive crops were damaged by that cold temperature. 2 years later, it was desiccated by high temperature.
Yes.
So yeah, I think these environmental anomalies we are seeing very extreme temperatures and weather patterns, and I think those may be evidence of climate change we are seeing. Yeah.
Thank you.
Thank you.